Okay, so let's look at this idea of printing from the driver here. I've got my tree.printAll workers. I'm going to change this thing to say, instead of printing it all, what it's going to do is it's just going to give me back a list of all of the workers instead. And so this thing isn't really print all workers. This is, I'm going to change this to get list of. And so now what you get back from that thing is a list of the same sort of stuff that you put in. So another way of thinking of this is I give you a tree, I give you stuff and say put it into a tree. Eventually I'm going to call you and say give it all back to me as a list. Okay, run through the tree and dump it into a list for me because I think lists are easier to manage. Well, if we do that, we'll have to go into the tree class and we'll have to modify the what used to be the print method, which it conveniently didn't change the name on. That's fine. So we'll change, oh, it did, get list of, there it is. Okay, we'll change this one to get list of internal. This is the naming convention is the same. And so now when somebody says get me a list of things, the thing that comes back as far as this thing is concerned is a list of whatever you put into the tree. Well, the rule here is that if you're going to return something, the Pfeiffer rule says we need to make the thing that we're going to return. So I'm going to make a list of E-type things, return list. We'll just make a new array list of only those worker type things or those E-type things. Make sure we do the import statements. Okay, so the rule was we'll make the thing, we'll do whatever work we have to do, and then we'll send back the list. Currently empty. Okay, now when we call getListInternal, we're going to pass it the list and we're going to say, here, whenever you encounter a node, dump it onto that list. And now when the work gets done, instead of it being print the stuff out, it's going to be return list dot add that thing, and we'll have to make sure that the other argument that we're sending in is one of those things. And now getListInternal, whenever we see it, we're passing along the return list as the stuff to dump into also. So we'll fix that to whoever we're asking to say, there's the place I want you to start printing, and there's the place where I want you to dump the stuff, whatever you find. Dump it onto that list. Okay, so now there's no print statement at that level anymore. Now we've got the case where the driver just gets a list of things back, and now it gets to do the printing. What did I do here? Oh, that should be a list of worker. Okay. Which means the driver can now say for worker who in temp list system out print line of who. Okay, and now if we run the thing, it still does the printing of the list, but now the work of doing the printing is moved up to the driver and the tree doesn't care anymore. Okay, and notice that now it just means it's a nice for each to go through and print everything out. Any questions about that so far? Because it's still not perfect. I want to make it better. Okay. This bugs me. The fact that I had to make a temporary list and then run the for each on the temporary list, right? That's a two-stage process there. It would be really nice if I could just run the for each on the tree instead and not have that temporary list in there at all. I don't have to see it. I just want to go through all of the items and run a for each on the tree. Give me all the items out. Why do I care? But now we encounter this little trick. It says you can't iterate through a tree. You don't have a for each requires an iterator and you don't have one. So we need to say that our tree will have that ability by writing the implements iterable. So it should implement iterable for E-type things. So that announces I have the capability to be used in a for each because I've got the iterator method. But now we get a complaint here that says you didn't write the iterator method. Okay. Let's go add the iterator method. And let me go find it first. Here's the iterator method. I'm just going to move it up a little bit closer to our print work. So here's our print work. Just let me paste it in there. Now the question becomes, how do you write the iterator?
Make the list in the iterator and then turn that list dot iterator.
You're close.
Oh, get list of iterator.
Get list of is already giving a list back. A list already has an iterator. So I could here, I suppose, just play this little game. List of E-type things, temp list is call get list of. And then here I can send back temp list dot iterator because list has an iterator. Ah, sneaky. Let's just see if that pays off in the driver. There's my for each. The for each is now happy. And now when you run the thing, it still prints it out. So even better yet, this thing is now as simple as it can be for this code. You just run a for each on the tree just like you would run a for each on the list. For each promises to give you out all the stuff. It just happens to give them out in sorted order. Let's go back to tree for a second and see if we can clean this thing up a little bit. Anything interesting about iterator versus get list of? We've already made a list here inside this method. And so there's really no need for the get list of method at all. I'm just going to delete that stuff. And I'm going to send back return list dot iterator. There was no need for two methods there, you could do it in one. So this now becomes, oh, okay, if they want an iterator, I don't feel like making one myself, but oh, tree or list has one, so I'll dump all of the stuff into a list using that method, and then once it's in the list, I'll just send back the list iterator. Easy, and then the list iterator does the work, it's iterable, so I'm just taking it out and using the list iterator to do all of the work for me. Okay, and that gives you the for each for the tree. So notice that this tree code is extremely short. It's almost like our beer game. There's not a heck of a lot to it, but it's extremely efficient at the same time as a nice little algorithm. Easy to read, really efficient to put things in, really efficient to retrieve things, all in just a tiny little bit of code. Now, let's do